So we're done with bars, but we're still going to stay in England, okay? So we're going to talk about the knights around the round table. So we have Sir Percival, Sir Lancelot, Sir Kay, and Sir Green Knight. As far as I know, Sir Green Knight does not have a real name. He's just the Green Knight, okay? Now they're going to pose for a portrait. There are no pictures, so this is a portrait. How many different ways can the Sir Knights arrange themselves in a row, right? So let's see. We have 1, 2, 3, 4 knights. Okay, so how many ways can we pick the knight that's on the left? Well, there's 4 knights, so there can be 4 different ways of filling that slot. Now, how about the slot immediately to the right of that knight? Well, 1 knight's already taken, so there's only 3 left, right? The one after that, well, 2 knights are already taken, so there's only 2 ways left. And then the last one, well, there's only 1 knight hanging around, so that's the only one we can pick. Again, these are multiplied, right? And I end up with 4 times 3 times 2 plus 1, which is 24, but it's better known as 4 factorial, okay? By the way, how many ways can I do this? By definition is 4 factorial, right? But where does that come from? It comes out of this argument, right? So you need to remember the factorial stuff if you can recreate this argument at will. All right, now what about around the round table? Here's my round table. Assume that it is perfectly round, okay? And what I'm going to do is, well, here I can pick 4, right? And then I can pick 3 of them to be here, and then I can pick 2 to be here, and 1 to be there. So it's the same answer as 4 factorial, right? Except, do you know what they had a round table? They actually had a round table because, well, King Arthur was very, very adamant about the fact that no one was above any other one, right? So by being in a round table, there was no preferred location. Whereas if you had a long banquet-style table, then you could have a head of the table where, say, King Arthur would sit. So actually, this is the very same table that I could draw like this. Of course, it's the very same table that I could draw like this. Very same table that I could draw like this. So what are we saying? Let's say that we start by picking Sir Lancelot, right? Because let's be honest, he was first among equals. Okay, so we pick Sir Lancelot. Sir Lancelot could go in the north position, in the east, in the south, in the west. Wherever he sits, then now I can put the second knight to be next to Sir Lancelot, next to Sir Lancelot's right, say. And then the third knight next to whoever that guy was, his right, and so on, right? So actually, Sir Lancelot could go anywhere, right? And then I can put the remaining knights in order, right? And they would all be identical. It would just simply be ways of rotating the table. So what happens is that this is really Lancelot, okay? Once I choose Lancelot, then everybody else can go in this order. So how many total ways are there? Only 3 factorial, okay? That's what putting them around a round table does. Since there's no head of the table, right? Then I can simply say, all right, so you go sit someplace, and then I'll see everybody else around it, right? And any other sitting arrangement, well, I can just rotate them, right? And I'll get that configuration. So there's only 3 factorial instead of 4 factorial. That's what happens when you buy a round table. That's kind of cool.